And what we need to do is to add the two lighting components together. So I'm going to use an add, and I'm going to take the color from here, and I'm going to add color from here. And then I'm going to put the result into our output color. Now, in fact, we can do the same with the F connection. So I take the F from here and connect it to an add node and put the output into the output. Now, this is not really an addition because F is not a genuine variable, but the purpose of making these connections is to tell the PPR renderer how our lighting model is constructed. And that should give us some specular lighting. Let's see what that looks like when we render. Now, because our surface is flat, we're not going to get very clear specular lighting. So let's go and alter our model. And at the moment, what we've got is a grid with some UVs on it. So let me edit the grid to make it more spherical. And I'll pause the video while I do that. So I've now edited this so that it's more rounded, and we can have a look at a render. And we see we're getting some specular effect here. For example, it's a bit brighter, but probably we need to change the parameters of our specular effect to make it clearer. So let's sort out the parameters of our shader, and we do that by having a look at the output node here, and we've got some parameters here to do with the gap and the width and height of tiles. We've got a variation ramp, and then we've got a number of parameters here which are to do with lighting. So I'm going to create a new group and call it lighting. And then if we go up to our material and promote material parameters, we should find that we have a lighting tab. Now, sometimes when you promote material parameters, it doesn't quite end up as you expect, and here we seem to have some parameters that are separating our different sections. Let's increase the sharpness of our specular highlight by reducing the roughness and reducing the sharpness. And let's have another look at a render. So let's have a look at the parameters and rearrange them so they look good on the parameter editor, and then we can change them to get a more distinct specular effect. So, as you recall, we do that by selecting the output node and hitting P to bring up the parameter list here. So we've got a group of parameters here which are to do with the planks. So let's select all of them, select those, and make this new group planks. And then we've got a group of parameters here which are to do with lighting, so let's select all of those and create a new group. and call that lighting. And let's go up to our wood planks material and promote material parameters, and then hit P to bring up a parameter editor, and we can see we've got our texture map. Let me change that so that it's our wood texture. We've then got our planks, and what I'm going to do here is make the width less. We've got our variation ramp, and I'm going to change this so that it's less of variation. Let's give it, say, a variation like so that there's a less pronounced variation between the light and the dark planks. And then our lighting, I'm going to turn the diffuse up a bit. I'm going to turn down a bit rather, and turn the specular intensity up a bit. And just so that we can see it, I'm going to make our specular color a bit red. Let's render that and see what it looks like. Well, we see we're still not getting a very pronounced specular effect. Let me try putting our texture onto a ball so that we can see that it's actually going to work. So let's hide our grid, lay down a sphere, dive inside, do a UV project, select, in this case, polar projection, and we're going to make it a NURBS sphere, and then move up one level and make sure that we have the right material applied to it. And let's enlarge it a little bit, and let's render that. And we see we are getting very small specular highlight just here. So we can go to our material and we can change the parameters here. Let's change the U roughness so that it's a bit larger, 0.25, and let's render again. And we're getting a bigger specular highlight. Well, we could continue to refine this shader almost ad infinitum, but I'm just going to add one final element, which is to add some noise to the gap between our planks or tiles. And I'm going to do this using the UV noise node. Now, UV noise is a node which adds noise to our S&T values. So we need to input S&T. And then it has a number of parameters here, which I'm going to create: the frequency, offset, amplitude, and roughness of our noise. And I'm going to color these. It also has this input P, and it needs this because it calculates the noise based on the position. Now, I could just try and feed in the position from a global variables node. Here is one. I'm going to output a single variable, which is the position. I could just connect this directly into the P connector here, but this P here is being measured in camera coordinates, which means that if my object moves relative to the camera, or the camera moves, then this value of P is going to change, even if in some sense the object is static. And that's probably not what we want. We don't want the noise to change. So what we need to do is use rest position. Rest position is a particular attribute that is sometimes attached to geometry. But what this node does is look for that attribute, and if it doesn't exist, use the incoming position, but convert it into the right space for using in this node. And the default texture space is in fact the space we need. So that gives us new values of S and T, and these need to be what go into our nodes here. Like so. Now let's have a look and see what that looks like when we render, but first I'm going to go up. In fact, first let's take those parameters and make them presentable for our parameter editor. So let's select all of these, create a new group, and call it UV noise. The other thing I'm going to do before we test render that is to revert back to our grid object. So I'm going to display our grid object and not our sphere object. And I'm also going to disable this edit node so that we are back to having a flat grid. And let's render that. We're getting a complex pattern here. It looks quite like cork, in fact, so it might be quite a nice pattern to keep. But the reason for that is that the extent of our UV noise, let's promote material parameters, the extent of our UV noise is clearly far too great. So let's take this amplitude right down to, I suspect we're going to need it even to be less than that. So let's take it down to something really small. And let's increase the frequency a bit. And let's see what that looks like. That's a bit more like it. Still a little bit too large an amplitude, so let's take it down to 0 and then take it up to 0.5, and the frequency is probably about right. In fact, let's try that again. And that's nice. That's giving us a very slight variation in our coordinates, so that it produces this slight variation in the planks. I also want to jitter these planks, and I can do that using a floor node. And I'm going to put our multiplied S value into here, and the floor node produces an integer that's less than the input value. So if the input value here was 1.5, the floor node is going to produce 1. And then I'm going to multiply that by a constant. And the constant I'm going to multiply it with is 0.5. And then I'm going to take this value and I'm going to add it to our t coordinate. So this needs to go into here, and the result needs to go in here, and the result needs to go down here. And what this should mean, if we render, is that our planks are now offset. And there's one final problem which you can just see here, which is that although we've got a constant gap width here, the gap in this direction seems to be wider than in this direction. And the reason for that is we're not taking into account the multiplication of the s and t coordinates by our width and height. So we need to correct this by creating a multiply factor using a divide node, and I'm going to divide the width by the height, and I'm going to use this. Let's move it over here. I'm going to use this to multiply our gap width, and I'm going to use the result here in our S filter step. And let's see whether that's corrected the problem. It hasn't. I've put that onto the wrong node, so let's swap that round. Let's put that onto the T filter step and have the original gap width onto the S filter step here. And now we can see that our gap is more even all the way around. There's another thing that I want to do to this shader, which is to add some parameter nodes which will allow me to export the different components of our lighting as extra image planes, which can then be reassembled in a compositor. Now for this purpose we have to be quite careful about what we export. The first thing we're going to export is the basic color information that's going into our Lambert shading. So I'm going to lay down a parameter node, and I'm going to label this paint export. In fact, it doesn't matter what we call it, because we're going to make it invisible, which means it doesn't show up in the parameter editor. And here on the export control, we're going to export it always, and it's going to be a color. And I'm going to take the result of this multiply node and put it into our paint export. And by convention, these are colored. Now, this export parameter here is something that will allow your extra image plane to pick up the variable here and create an image plane which just contains this value for each pixel. And it's quite important what you name it, because there's a naming convention. If you have several different objects with several different shaders, they all will need to have a export parameter called paint export if you want to create an image plane of paint exports. So paint is just the incoming color. Then we need the diffuse illumination, but we need to be quite careful about what we are actually exporting here, and I'm going to call this diffuse export, which is the standard name for this. And again, we're going to always export it. We're going to make it invisible, and we're going to make it a color. And let's color it so. And in this case we want to put in the illumination, but we also want to multiply that by KD, because if we recall, this illumination value just gives you the lighting. It doesn't take into account the diffuse color, which is fine because we're already exporting that, but we do want it to take into account this factor KD. So I'm going to need a multiply node here, and I'm going to need to connect the illumination into here, the product into here, and KD into here. And that should ensure that we're getting the right export here. And then I've in fact already got a node set up here for specular export. Let's start that again. So lay down a parameter, and we're going to call this specular export. We're going to make it invisible, and we're going to always export it, and it's going to be a color. And let's color that again. So again, we need the illumination to go in here, but again, we need to multiply it by the ks factor. So let's multiply and ks. So let's have a look and see whether that works. Let me go up and into our output network, select the mantra node, and I want to create an extra image plane. So I can do that by clicking the plus button here on the output tab of the properties subtab. So I've now created an extra image plane, and I can either type in the vex variable here, or I can use the drop-down menu to choose Material Paint Export, and that will automatically set this up for me. And then I'm going to add another image plane. Let's go down to that, and I'm going to choose Diffuse Export, and then I'm going to add a final image plane, and I'm going to choose Specular Export. And then when we render this, we should find that we have our Paint Export, which is just the color, Diffuse Export, which is just going to be the diffuse lighting, so no color, just a flat, and the Specular Export, which will produce nothing in this case because we're using a flat surface. Let's go back and select our sphere and re-render. And now we see we've got our sphere. That's our color. That's our diffuse lighting, and that's our specular lighting. That brings us to the end of this tutorial on writing a basic shader in Houdini. I hope it's been useful.